So that's where we're going to go with this. Now, the first step here is to convert our 5,400 RPMs into radians per second. So 5,400 rotations per minute, and then we're going to multiply that by 2 pi radians per rotation. And then we also want to get away from minutes and into seconds. So we're going to do 60 seconds per minute. We're just doing a straight conversion from RPMs to radians per second here. And we wind up with 5,400 times 2 times pi divided by 60. And we wind up with 565 radians per second. That is the final speed of the rotational speed of this thing. Okay, so this is the final velocity. Now, acceleration is a change in velocity divided by a change in time. And we went from 0 to 565 radians per second in 2 seconds. We can figure out the angular acceleration is 565 radians per second divided by 2 seconds. So we divide this by 2, and we get 283 radians per second squared is the angular acceleration. All right. Now, the book does the same sort of thing that we did over here using 1/2 AT squared or 1/2 alpha T squared to figure this out. But I want to show you a slightly different way just so you can see how it's done. And you may, well, you never know when you might need it. So, all right, so the equation that we're going to be using is our old friend VF squared equals V naught squared plus 2A delta X. On the AP Gouge, they don't translate this for you into rotational terms, and so I want to show you how to do that. So this is what it looks like. The V's turn into omegas, so omega final squared, that's the angular velocity, is equal to omega initial squared, that's the initial angular velocity, plus 2 alpha, that is the angular acceleration, times delta theta, which is the radians of rotation instead of the meters of straight line distance. Okay, so this is the equation that we're going to use. Now, our final angular velocity is this one right here. That's what we figured out what the final speed was. That 5,400 RPM translated into radians per second, 565. So we're going to go 565 radians per second. We need to square all that because it's omega squared, equals the initial angular velocity, which is 0, because we started from rest, plus 2 times our angular acceleration, which is 283 radians per second squared, times delta theta, which is what we want to figure out. How many radians of rotation has it gone through during this entire process? Okay, so do the math. 565 x squared divided by 2 divided by 283, and we wind up with theta equals 564 radians. Okay, now we don't want radians, we want revolutions. So we need to convert this radians into revolutions. So we're going to multiply this by 2 pi radians per revolution. And I'm running out of room here, so I'm going to put the answer over here. 564 divided by 2 divided by pi equals 90 rotations. That's the answer. All right, and as I said, that's on page 197. They don't use this equation. They instead use this one in their process, but they get to the same result. Okay, that should be enough to get you unstuck.